Pythagoras' theorem, a squared plus b squared equals c squared, is a rule that applies to any right-angled triangle. Now, Pythagoras was an ancient Greek guy who loved maths and loved looking at patterns, and he discovered this rule. So that's why it's called Pythagoras. It's named after him. Now, when we're talking about the a plus the b plus the c, there's a few things we need to point out, is that C actually means the hypotenuse. So hypotenuse is a funny word, as the joke says, but it's actually the name of the longest side, and it's the side opposite the right angle. The other two sides we just call A and B. We could have called them X or Y or any pronumeral. That's a pronumeral. Which is just a letter in place of a number, but A and B works well in this case. So Pythagoras only works for a right angle triangle. So if we're looking at a right angle triangle like this ladder leaning up against a wall, you can see the hypotenuse here is the side of the ladder, that's the longest side, and the ladder's making a right angle at the bottom where the ground meets the wall, because hopefully this wall's at 90 degrees, because that way the building's standing up straight. So the other two sides are our A and our B. So we can give them their names, A, B, and our C. I've made them different colours just so they stand out. So if we wanted to know how long a ladder would need to be, or a set of stairs like this would need to be, to reach from the ground to the opening of the wall, it'd be very difficult, well, a bit tricky to measure that, but especially with certainty. And when we're building something like stairs, we don't want it too long or too short, we want it just right. So we can use Pythagoras to work that out, as long as we know how far away at the bottom the stairs will be and how far up the wall they need to go. So the builder has measured the wall up to the door, and the measurement from here to here, from the bottom of the wall to the door, is 1.2 metres. The builder's also measured how far away this ladder would be. Now he'd usually work that out based on the angle that it actually needs to sit on, so roughly how far away that angle would need to be, and in this case it's 1.8 metres. So how long would the ladder need to be? Well, let's have a look. We've got Pythagoras, a squared plus b squared equals c squared. Now it's always important to draw it out properly and write down your formula, because that's good bookwork and it helps you keep track of what you're doing. So let's have a look. This 1.2 metres will be a squared, so let's put that in, 1.2 squared. Now we have to add on b squared, and in this case that's going to be 1.8 metres squared, and that equals c squared. Now we don't know c, that's what we want to find out, so we do need to leave that there. Now when we pop this into a calculator, 1.2 squared is 1.44, and we have to add on 1.8 squared, which is 3.24. That equals c squared still, haven't changed that part. So now we add these two numbers together. So 1.44 plus 3.24 is 4.68. And still haven't changed c squared. Now to work out what c is, we have to remember what the opposite of square is. So if we remember that x squared, the opposite is the square root, to the power of 2. They're the opposites. So here, to get c on its own, I need to square root 4.68. So notice I've taken the c off, the squared over here off the c when I moved it down here, and I've replaced it with the square root over here. That's the same as saying square root over here and square root over there. So 4.68 square root will be 2.16 equals C. So C equals 2.16 meters. Okay, so here's a different real-life problem using Pythagoras. This is a gate. So in this gate, we knew the length of each of the space between the wall and the fence post, and that was 100, I'll write it down here, 110 centimetres. And we knew the height the gate needed to be because it needed to fit the space properly to the height of the fence post, and that's going to be 80 centimetres. How do we know how long to cut the diagonal, the support strut of this gate? Well, Pythagoras can help us again. So here we're going to draw those same measurements on just the triangle. So let's take away the picture. So it's 110 centimetres and 80 centimetres. So here we're going to need to write down Pythagoras. So Pythagoras was a squared plus b squared equals c squared. So a squared is 110, so we'll write 110 squared, where a squared will be. It doesn't matter which one you're using in which place here, the a or the b, as long as it's not the hypotenuse. Now, b squared will be 80 centimetres. So 80 squared equals c squared. Okay, so if we put this in a calculator again, 110 squared is 12,100. And 80 squared is 6,400. Okay. Next step, we have to add these two numbers together. So 12,100 plus 6,400 gives us 30,600. And we still equal c squared because we haven't done anything to c squared yet. When we do the square root of 30,600 and the square root of c squared, we end up with c and 174.9. Now this is the length of our diagonal. 174.9 is probably a bit too accurate for a gate. It's hard to saw to 0.1 of a centimetre, but we can round this, and because it's 0.9 we would go up. So 175 centimetres. Okay, here's a classic ladder problem. The ladder's leant up against the wall. The ladder is 5 metres tall. But this person wants to know if the ladder, their 5 metre ladder, will let them reach the gutters of their house. Their house is 4 metres tall, so we need a ladder that's going to reach 4 metres or more up this wall. So we're looking for a number that's over 4 metres. The ladder also must be 2.5 metres from the house wall. And the question is, will they reach? So here's the diagram of our problem here. So the first thing is we have a 5 metre long ladder. Now the ladder is going to lean up on the wall, just like in the picture here, and the ladder's 5 metres long. So we can draw this out as a picture. Again, the wall should be a right angle triangle, so that's nice and easy. We're hoping that this length here, which we'll call C, which we'll call A, is 4 metres or more high. Otherwise they won't reach their gutters. And the last piece of information we needed to know was that it has to be 2.5 metres from the wall. So let's use some Pythagoras to work this out, because we have a right angle triangle, so we can use the a squared plus b squared equals c squared method, where 5 is going to be c, our unknown is going to be a, and let's call this bottom side b. So So here we've got a bit more room now. Remember, we're hoping for A to be greater than 4 meters. Let's hope we're right. So we have Pythagoras, A squared plus B squared equals C squared. We have an A that we don't know this time. So we're going to have to do some rearranging of our equation to work out this answer. Our B is 2.5. So we've just substituted B equals 2.5 into our question. Now C was 5 meters, so we can substitute that into our equation too. And as long as we only have one unknown, we can solve for this equation for the value of A. Okay, so first thing is, let's get rid of these squares as much as we can. So A squared plus 2.5 squared is 6.25 using our calculator, and 5 squared is 25. So now we need to get this pesky 6.25 on the other side. So we need to look at how it's attached to the A squared, because we want that all on its own so we can solve for A. Well, if you have a look, in between there's a plus sign. So we need to do the opposite to get rid of it. So if we go A squared plus 6.25, the opposite of plus is minus. So we're going to go minus 6.25. But just like a set of scales, whatever we do on one side, we have to do on the other. So we're going to go 25 minus 6.25 on that side too. So what we've ended up with is minus 6.25 on that side and minus 6.25 on that side. So the balance is there. We have an equal equation. It's equal on both sides. When we do this maths, 6.25 minus 6.25 means they're both gone. They both equal 0. So we're left with A squared equals 25 minus 6.25. Now we can work out these number values. So 25 minus 6.25 is 18.75. Now we have that square we need to get rid of. We just want A on its own. Remember that A squared equals A times A, just in case you're trying to remember. So we just want one A left. Remember that the opposite of A squared is the square root of A. So let's square root both sides. Square root of A squared and the square root of 18.75. So now we're left with A on this side, and the square root of 18.75 is 4.33 meters. Now we haven't finished answering the question, even though it looks like we have, because we've come up with the value of A. Remember the question said, will the ladder reach? Well, we needed A to be greater than 4 meters. So is A greater than 4 meters? Yes. So the ladder will reach. And it'll reach by 0.33 of a metre, or about 30 centimetres. So a nice bit of overhang there. Here's another real-life problem. An old restaurant building needed to build a ramp over their stairs to allow wheelchairs to access them. Now, they needed to know how long to build this ramp. How far will it stick out? How long will the boards need to be? So the builders looked for Pythagoras. Here you can see a side view of the steps, and they knew that each step going up was 10 centimetres high, and there were 4 of them. So that makes this side of the triangle makes this side of the triangle 40 centimetres. Now, the other side of the triangle, they could work out because they knew the depth of the sides of the stairs. So the depth of each stairs was 20 centimetres high. So I find underlining the information in the question that I need and drawing it on the diagram helps me work out what it is that I am trying to solve. So now I have this lovely triangle. I have a base of the triangle, a right angled triangle, because it is right angled, that is 20 centimetres. Oh, sorry, not 20 centimetres, there's 1, 2, 3, 4, there's 80 centimetres. So 80 centimetres. And I have a height on my triangle that is 40 centimetres. Sorry, my pen's not working 100%. So now I need to find out what the hypotenuse is of my right angle triangle, which I'm going to call C. Okay, so how did I get those numbers for the triangle? Well, if I've got 4 steps and they're all 10 centimetres long, then I have a total length of 40 centimetres, because 10 plus 10 plus 10 plus 10 is 40. I could have also done 10 times 4, which is the quicker way of getting 40. And that's really just adding this vertical height here and moving this one over here and moving this one on top and that one on top of that. So you can see that they are the same length. Now to get the bottom length, I do the same thing. So again, each step is 20 centimetres wide. So if I take this 20 centimetres and put it here, and this 20 centimetres and put it there beside, you can see they don't overlap. They're all one after the other. So you can see that I could do again 20 plus 20 plus 20 plus 20, or I can go 20 times 4, and I still get 80 centimetres. So now I've got my triangle C. Okay, so now we have our triangle. I've taken away all the word question parts, the picture's gone, we're just down to a very simple diagram of a right angle triangle. So here's our right angle, and opposite is our hypotenuse. Our other two sides, we can give the names A and B. So now we can use Pythagoras. So what was Pythagoras? Here it is. C squared equals A squared plus B squared, where C is the hypotenuse. So we can do some substitution now. Our 40 centimetres here goes in here, and our 80 centimetres here goes in here for B. Next step, we have to do the squares. So 40 squared gives us 1600, and 80 squared gives us 6400. We now have to add them together, and we get 8,000, and then we need to do the square root so that we can get C on its own. So remember, going this way, we're doing the square root of C squared, and here we're doing the square root of 8,000. When we put that into our calculator, we end up with 89.44 centimetres. Now that has been rounded slightly. But to build this ramp, we know realistically that to say to the builder it has to be exactly 89.44 centimetres is a bit too precise. So we say that the ramp needs to be at least 90 centimetres long. We wouldn't go round down to 89 centimetres because it just wouldn't be long enough. Remember, it would be 0.4 or 4 millimetres too short. So we say at least 90 centimetres in this case. So that brings us to the end of the presentation. What we need to remember is Pythagoras. Pythagoras only works on right angled triangles, like this one, and we have to name the sides, And Pythagoras is a squared plus b squared equals c squared, but c has to be the hypotenuse. Once you know where the hypotenuse is, you can name the other two sides, a and b. And it doesn't matter which way up your triangle is. You can move it all about. Remember that C will always be opposite, directly opposite your right angle. So you can see, here's the right angle, directly opposite is C. Here's the right angle, directly opposite is C. Right angle, directly opposite is C. And the name we give our right angles is, or our C is known as the hypotenuse. The other important thing to remember is that the opposite of c squared is the square root. So when we say c squared square rooted, we say we have c. Just the same as the opposite of plus is minus. And the opposite of multiply is divide. I hope you've enjoyed this video. Make sure that if you've missed anything or you'd like to check anything else out, make sure you go back, rewind, press pause as often as you need to. Thanks.